Welcome to today's webinar. We're going to be talking about mastering the maze, democratizing data engineering while modernizing your data architecture. And I stumble over that first word very, very often. Let me quickly introduce our wonderful two speakers today. First and foremost, we're very honored to have Mike Ferguson, Managing Director of Intelligence Business Strategy. He is a thought leader in business analytics, machine learning. He's just hosted the Big Data London, and we're very, very, very pleased to have him with us today and to present our session today. Also alongside him is my boss, Dr. Nick Gollowin, the technical founder of Data Virtuality, and he will then, after Mike, also explain and show a little bit of our platform. And then right at the end, we'll have some Q&A. You can ask questions in the Q&A, which we then kind of address at that very moment in time. Now, with no further ado, because we have a full session today, let me pass it on to Mike. Thank you very much, Mike. Please take it away.
Thank you, Tammy. So good morning, good afternoon, good evening, everyone, wherever you may be. Thank you very much for taking time out of your busy schedule to come to this session. So my presentation is really about how can we handle the democratizing of data engineering while at the same time modernizing our data architecture. So what I want to do is explain that. This is just a little bit about my company. As Tammy kindly said, I just got back from chairing Big Data London, which was an enormous conference in London last week. Yeah, I want to talk about the demand for data and AI and how that's growing incredibly at the moment, and why, in order to do that, we need a data foundation. And look at what's going on in organizations today, and while there are problems, and look at how we are seeing this evolving in order to address these problems through the emergence of data products, but also some of the obstacles in the way of helping companies to produce those. And look at what we need in order to be able to do that, but also look at the fact that there are different architectures, data architectures emerging, and companies may choose different ones for their individual needs, and how even more technology advances are causing changes to data architecture and will continue to do so over the next couple of years, and how you need to be versatile and flexible and be able to continue to handle data integration in that kind of an environment. Okay, so let's first of all take a snippet from a survey done this year, which you can see, despite a slow economy, in this particular survey, almost 88% of companies surveyed still said, even though the economy is slow, we are increasing our investment in data and AI. And for good reason. As you can see, almost 92% of those companies said they are getting measurable results, and that figure is projected to be higher next year. And you can just see this. The latest phenomenon in AI is generative AI, and just an explosion of job postings. Took a few quotes from different press articles, both sides of the Atlantic, and you can see just an explosion of jobs appearing just in the area of generative AI alone, never mind the existing shortage in AI, and of course, all of it depends on data. So executives' expectations are now huge around data and AI, particularly the fact that they see it disrupting business. They see it as a way to really make significant inroads into improving productivity, reducing costs, and improving efficiency, and at the same time improving personalization and driving up revenue. But those expectations are everywhere. They're in the boardroom, in every part of the business. But if you're going to do this, you really need a high quality and governed data foundation to be able to do it, because AI is dependent on high quality, consistent data. So then the question is, well, what about the data foundation? Because when we look at data engineering today, we quickly realize that most companies don't really have a data foundation. What they've actually got is multiple siloed analytical systems. And so there is data engineering activity going on for data warehouses, for different data science projects, for example, on cloud storage. We could have data engineering going on to integrate data for graph databases, for particular kinds of analysis there, or to analyze live streaming data, perhaps coming in from IoT devices or from financial markets, or even transaction systems offering change data capture. All of this is going on in different silos with different tools. And so the people working in those silos often don't share metadata. You can't share metadata between tools. And so they're not really um, aware of what's going on in any other silos. So I wouldn't really call that a foundation. I would call it, just siloed analytical activity. So we're building these point-to-point pipelines just for a single target system, whether that's an individual machine learning model that a data scientist is developing, or whether it's a data warehouse, that's being shared by multiple end users with BI tools. Doesn't matter. We've got into building these pipelines, integrating data for a single purpose. And so, not surprisingly, we're often integrating many, many times the same data, so taking the same data from the same sources and integrating them for individual purposes. And so repeatedly doing that work and potentially doing it in an inconsistent way so that the data is potentially inconsistent across multiple analytical systems. At the same time, over the last 10 years, we've seen a frenzy of activity, both in business intelligence and data science, with people using a variety of different tools. And of course, business intelligence tools for quite some time now have had self-service data preparation built into them. Multiple different tools have that. Similarly, data science workbenches also have had the same. And so people are using all of these tools in addition to what we saw already. And so what we've got is self-service data preparation going on all over the place. And so if it's ungoverned, you can very quickly get all of these standalone projects leading into chaos across the enterprise. And as one a senior executive said to me on my customer base, that everyone is blindly integrating data without attempting to share anything that they're creating. And so if you think we had a lot of silos before, and now we've got even more of these silos, and then you kind of say, well, surely that's going to lead to the same data being integrated again and again, even more inconsistency. How many times are we now doing it? And that's just potentially going to lead to inconsistency and disagreement across lots of different front-end tools, potentially leading to the famous phrase of garbage in, garbage out. It's not so much garbage necessarily, but it's certainly inconsistent. That's for sure. And so if you look at the way in which we've been doing data integration across all of these individual projects over the last several years, what you begin to realize is what we've been doing is building, producing data a bit like the picture on the left. And so that everyone's doing their own thing, producing data, but we don't really know if this data has already been invented or integrated somewhere else. We just don't know about it, so we can't see it, so we build it again. And so what we really want is the picture on the right. We like the data to be built once, reused everywhere, organized, easy to find, so that we can quickly accelerate our overall development. And at the same time, now that data and AI has really become ubiquitous, it's everywhere across the business. Everybody wants it in almost every single department. And as a result of that, what we've got is a situation more and more data sources are emerging. And at the same time, more and more demand from right across the business from business users. And so the people doing this data integration, which is often centralized IT or even data science, have just become a bottleneck. and can't keep pace with the demand that's going on around them. And so you kind of have to say, well, something's got to give here. We need some way to solve this problem in order to be able to deliver data more rapidly for people to pick up and use so that they can produce new competitive insights. And so that's one of the key reasons why we saw the emergence of what was called data mesh, which was actually first written about, I think, in 2019. But really, it was last year where data mesh kind of really went viral. And the whole idea about this was to decentralize data engineering, to break the logjam, to break the bottleneck, and say, can we get more people around the organization building, engineering data and producing what are known as data products that they can share across the enterprise, which basically means that we need to upskill a lot of people around the enterprise to be capable of doing data engineering, not necessarily to have the same amount of skills as IT professionals, but we're trying to get many more people to do this to speed up our ability to build a data foundation from data products and incrementally build those up. So data mesh is really about decentralizing data engineering process, if you like, and getting multiple teams involved rather than relying purely on central professionals. So what do we mean by data products? Well, as you can see here, I've made a distinction between data products and what I call analytical products. So therefore, to be clear, business intelligence reports and dashboards and machine learning models and AI bots and AI apps and these kinds of things, these are analytical products that are built from data, and the data comes from data products. Data products, on the other hand, can either be physical data sets or virtual views of data. So it looks integrated, even though the data may not actually be physically stored anywhere. Or it could just be the metadata that is used to produce the data product, which could then be invoked on demand as a pipeline to then produce the data product on demand. And so therefore, pretty simplified view of a data product rather than trying to say it's all of these other things as well. And that's important because it gets down to basics as to what kind of data is there within organizations and how do you build on it. And one of the key things is that there's a kind of hierarchy of data product in the sense there are foundational ones, things like customers and products and orders, shipments and payments and employees, suppliers. You know, these are four pillars of data within the enterprise. They're like building blocks to build a data foundation. And on top of those, we can combine them and get even more valuable data products from integrating those foundational ones or filtering them, and then take it up again to yield more insights. So a very basic way of being able to get this going is just to define the master data entities and the transaction types within your industry. You know, if you're a bank or if you're a retailer or you're an insurance company, as we can see here, there are key master data entities within your organization. Similarly for transaction types. And these can be the foundation data products that you can create within the organization. Increasingly, we're also seeing the emergence of data concept models, which are not logical, detailed data logical models at all. All they are is just the basic data concepts within your enterprise to represent the key data within your organization and any relationships between them. And this is growing rapidly in value and rapidly in popularity because businesses quite easily understand these data concept models. And from there, you can take each of those data concepts and say, okay, let's build that out. Let's define the uh, attributes that describe each of those data concepts in a data catalog or business glossary within a catalog. And then we can discover where the data is to be able to build each of those as a data product, and using a catalog to do that discovery. And then we can define the metadata, if you like, to integrate and engineer the data from the disparate sources where that data currently exists in order to be able to produce the data products that we want. And then we need to publish them somewhere so that they're available to others to find and use. And that is a data marketplace. So the idea here is not to build pipelines for a single target system. The idea is to build data products once and reuse them for different analytical use cases. Here you can see, different machine learning models, a graph database, a data warehouse. But we also need to be able to accommodate data integration while these architectures start to merge and change. And certainly that's already beginning to happen within the organization. We're starting to see deeper integration between some of these different data stores. And we should still be able to handle that so that we can provide data products once and allow them to support multiple analytical workloads, whether it's to do with business intelligence on a data warehouse, graph analysis, or data science. And so, once we've defined the common definitions for data products within a glossary, you can create a schema for each data product, produce the metadata to the pipeline, if you like, to create the data product. And then the consumer has a relatively easy job. They can just pick these ready-made data products and assemble them for their different use cases. So almost like these data products are building blocks. They're like Lego bricks almost. And if we can get global identifiers for each one of these data products, then they should be able to hopefully snap together a little bit like Lego bricks. So here you can see an example of what I mean. You create these data products in a marketplace where you have, in this case, an example of retail. You have customers, you have products, you've got your sales, you've got all the different channels that you can sell, whether it's online channels or individual stores. We have things like shipments and returns, distribution centers, etc. And then I can pick whatever ones I want for example, a data mart. So I just assemble the data mart using the appropriate data products in this case, so I can say who's buying what, through, where, when, and then even build aggregate data products on top of that. It's kind of a hierarchy approach that I mentioned earlier. But the problem with doing this at the moment is not just about democratization of data engineering, about the decentralization approach. There's a bigger challenge out there as well. And the challenge is that data is increasingly being distributed further out. It's not held in one place anymore. We now have data in software as a service applications, which are running often in the data centers of those application vendors. We've got data in multiple different kinds of database, in multiple clouds. We've got data in multiple kinds of data store on premises. And we've got data streaming in from the edge, whether it's from IoT devices or even financial data coming from external markets, or even live transactions. As soon as they are recorded in our transaction systems, we're doing change data capture to bring that data in immediately for analysis. So data is constantly spreading out. And so therefore, if you're going to be able to deliver data products and have multiple teams participate in doing this, we need technology that's going to connect right across that distributed data estate. We need the ability to discover what data is out there, and then we can use a common platform to build those data products where multiple teams are able to share things, to share metadata, to share both data and things like transformations and whatnot between different teams and accelerate it. We also need the ability to support multiple data integration techniques, whether it's change data capture, handle things like live streaming data or transactions. We might need ETL, we might need ELT, we might need to have virtual views, whatever is appropriate. And the beauty of a data fabric is we have the ability to leave the data where it is, connect to all of those disparate sources that are out there, then discover what's available, and allow the teams of data producers to then build the data products that are needed. But we also need the ability to then publish those somewhere, so that we can then share them in a compliant manner and govern who's got access to them, all from a common platform. At the same time, however, as I mentioned before, data architecture is evolving. And since the emergence of data mesh back in 2019, what we now see is a whole range of different architecture options available for people to do decentralized development of data products. And so, you could use cloud storage with multiple zones. You could use multiple zone storage accounts across a single cloud or multiple clouds. We could do it on the lake house or even multiple lake houses. We could do it in data warehouse staging areas. We could do it through virtual data products or even on Kafka. And all of those right now are being promoted in the marketplace, and companies looking at each of them and choosing whatever ones that they feel appropriate to their overall needs. So the problem is that we now got multiple competing architecture patterns that have emerged to be able to build data products and create the data foundation to support multiple analytical workloads, which is causing a little bit of confusion in the market. But it also says that we need flexibility as to whatever architecture is chosen. We need to be able to accommodate it. So here you could see, could be a zone data lake, could be a lake house, could be a data cloud, which is really an extended data warehouse on the cloud to support multiple kinds of data. We could have virtual views on data lake, on lake houses, or leave the data where it is. I've even seen database vendors last year offering external tables pointing at files in cloud storage. So you kind of ingest your data into cloud storage and then produce data products there and have data warehouses point to those. But again, there's some issues with this. Things like schema governance, things like ability to update some files in cloud storage without the any kind of integrity guarantees, or even the performance of cloud storage being problematic. But I think what's happened recently is we've seen in the last 12 months big changes around all of this, and particularly through the emergence of what I call open table formats. And three of them in particular, Apache Hudi, Apache Iceberg, and Delta Lake. And as you can see on the screen here, several vendors announcing support for all of these. And so wide adoption here, which means that architectures are changing. And as you can see with open table formats, it's not just the database that can query the table or even update it. I can have other engines updating it at the same time that are outside the database. Whereas on the right-hand side, proprietary table formats would only be able to be updated and by the database itself. An example of open table formats shown on the bottom here with Google BigQuery example of pointing a table directly at Iceberg table formats. And so what's actually going on here is that we're getting data warehouses now integrating with lake houses, and as opposed to them being, use one or the other, we're getting one integrating with the other, but also allowing multiple engines to go and update those tables, and at the same time allowing those tables to exist not only on a single cloud, but on multiple clouds, so that I could potentially want to be able to run queries that confederate across multiple open tables and gain access. Not only to produce data products, we want to produce data products in this environment, but we also then want to consume that data and use it for multiple analytical use cases. And we need somewhere to publish all of these data products in some kind of marketplace. And more recently, we've allows people to then shop for ready-made data that's already produced that they can pick up and go with, rather than wait or have to go back to zero and build everything from scratch. So that opens up a whole set of requirements, if we're going to want to be able to do this, to be able to accommodate all of this. What we're trying to see is, companies need data integration technology that supports the development of data products, irrespective of the architecture chosen. And not only that, but to be able to accommodate changes in the architecture when we see things like open table formats emerging. So what that means is the kind of requirements we need are things like want to be able to run on premises or in the cloud or both. We want to be able to connect to a broad range of data sources across that distributed data estate that I mentioned, including software as a service applications, including relational databases and IoT streaming data, SQL databases, open table formats that I mentioned a moment ago. We need to be able to have more than just centralized IT professionals working on integrating data. We need citizen data engineers to be able to do that. And as generative AI emerges in tools, that we need that too, to help make it easier for lesser skilled people like citizen data engineers to still be able to integrate data through a simpler user interface and automate some tasks. We want to be able to have multiple decentralized teams build both virtual data products or even persist data products, create physical data products. We'd like to be able to support multiple techniques for data integration. We'd like to be able to support different architectures and accommodate changes to that, and to be able to share metadata across all the teams so that data integration metadata is in a single place. We'd like also to be able to create virtual views on data, irrespective of whether it's in a lakehouse, whether it's in a data lake, whether it's in a data warehouse, or a combination of those things, or in disparate other sources across the enterprise. And we want to be able to persist those if necessary, if they're very popular and are needed on a very regular basis. We'd like to be able to actually physically persist those in a data warehouse or a lakehouse, for example. Publish them all so that people know what exists, and be able to govern access and create a semantic layer to give people consistent meaning. And that's really where data virtualization comes in, because what we've seen in data virtualization is the ability now to connect to a broad range of disparate data sources. We've also now got the ability to build virtual data products, but as you can see, this large red arrow that I've shown here, for the most popular ones, we can persist those in analytical data stores. And we can also create a marketplace where we can publish those data products and make them available. And if they're all with common business data names, then we're creating a universal semantic layer, same meaning across all tools, so that all tools accessing those data products effectively get the same data with the same data names and the same meaning. But we can go further than that. As we change architecture and we see evolution happening because of things like open table formats, and we see data warehouses now integrating with lakehouses as opposed to being seen as an alternative. what we now have is the ability to still accommodate all of that, still be able to create virtual data products. If we want to persist popular data products, we can publish them, persist them in data warehouses. We can persist them potentially in a lakehouse in open table formats. We can also connect to other disparate sources, whether it's streaming data, to handle change data capture or live streaming data. Also remember that open tables support live streaming data directly into the tables. But the whole point being is that we can still build these data products within the virtualization layer, publish them in a marketplace, and allow people to build on top of them. And for the popular foundational data products, we can persist those if needs be. So simplifying access, still supporting federated query, still supporting multiple data integration techniques, and accommodating changes in underlying data architecture. And then we have a marketplace, as I said, to publish these data products for people to shop and find it. But what we want to do is prevent people from creating lots of copies. We don't want to create lots of copies of these data products. What we want is to just grant access to them. And again, data virtualization makes that possible through consistent common data names and can govern it all from one place. And so therefore we're not we're not creating lots of data redundancy by everybody asking for copies of the same data products. So to kind of conclude, Dan, I think companies are now wanting to choose whatever data architecture best suits their needs and don't want it to cause any problems. They also want to be able to change those data architectures without causing problems. And then they need a common platform to be able to integrate data and share metadata across multiple teams and therefore coordinate, decentralized development of data products and be able to therefore incrementally build these up to create a high quality data foundation of reusable data products supporting multiple analytical workloads. Data integration has to be able to accommodate citizen and professional data engineers and different data integration techniques, support physical and virtual data products, publish them in a marketplace, and allow sharing of those without the need to copy it. And if I look at it, certainly from what I can see, it seems that data virtualization has evolved to be able to support all of these things within a modern data architecture and accommodate changes to that architecture as technology evolves. So I hope that's given you a good idea of what's potentially available. So I'd like to say thanks very much for listening, and I'm going to pass back to Nick.
Thank you, Mike. Nick,
Oh,
all yours. No, not to me, but I just want to say thank you.
Yes, thank you. Thank you very much, Mike, for this big picture of what's happening in our space. And by the way, if anybody has more questions to Mike, feel free to ask them in the Q&A session. They will be answered then after my presentation. A couple of words about me. I am the founder of Data Virtuality. I have technical background, so all my professional life, I was working in data integration projects, trying to bridge this gap between data and people, trying to help technical people get the data out to feed all the business initiatives and the business growth out there. I was researching in this area in basically doing research as well. And what is our view on this topic of democratizing the data engineering while modernizing the data architecture? How do we think? What is our way to relate to those things which Mike was telling? And to explain this, we like to use the notion of data OS. So it's really just an analogy for us. like to think about. So it's not a kind of Linux clone you can install in your server and do all things data, but it's more a concept which we like to use when we think about how to best enable organizations and the people in the organizations to use the data better. And let me explain this analogy a little bit more. So in the very old days, which I didn't live at those days, but it was really happening when computers just came out. People were really programming basically against the hardware, right? So there were like machine code entering in the central processor, which was doing things with technical components, with peripherals and so on. But pretty quickly it was found out that if the usage is growing and if the technology is growing, there's a need for this central layer in between. And which is called operating system, and what are the main things about this layer? So first of all, it should provide interface for the users, for the people to work with the system. And the second thing, it should of course also provide interface to different applications to work with all those different technical things we have behind the scenes. You know, with all those technical components which can be very different, which can work in different way, but still there should be the same interface. And there should be also libraries and central services to provide things which are needed for everybody. And there should be also a kernel which is kind of doing the work and tying all those different technical things together. There should be also interface to hardware layer, the interface which knows how the different hardware pieces inside of a computer are working. So they could be working differently, different protocols in different way. There should be something which simplifies work. And of course, this should ideally be ubiquitous. It should work in different situations with different devices, with different technologies, and so on. So these are the main things which we kind of, for us, we see when we are talking about the traditional OS. And once we have listed this, I think it becomes pretty easy to see how thinking about the solution for the data integration problem in terms of operating system helps us bring things forward by providing better interface to people, by providing better interface to different applications and use cases. This is what Mike also mentioned, that there are growing number of use cases and different applications. At the same time, provide some centralized services, provide the abstraction of the hardware layer of all those different bits and bytes out there, and also, of course, be able to work in different conditions and different use cases. And this is what Data Virtuality Platform is offering. These are the main components of Data Virtuality. This is my favorite slide, to be honest, as a technical person, but I will also try to go very quick through it, just to give you a glimpse of those different things we have. So one thing which we are offering is a large number of connectors to different systems. And those connectors, it's data warehouses, data lakes, flat files, of course, very important, cloud APIs and software as a service APIs, as Mike mentioned. A lot of things are happening now, so the data gravity is moving there. So we can connect to different systems. And not only this, we also know the different ways of working with those systems. So for some systems, we can provide the way of accessing the data directly, but also replicating data out of the systems, accepting data streams for streaming systems, doing change data capture. This is something which a couple of connectors are supporting, and we are growing also this functionality for other connectors as well. So this is our hardware abstraction layer, if you think about this data OS analogy. And if we jump on the other side and talk about people and applications, so this is where we provide the interface both to different applications, which can be BI applications, data science applications, dashboards, or maybe just Excel on one side. but also provide interface for people, persons, data engineers, or maybe business data users to both work with the data on a technical level, but also consume data over a central interface, like Mike described, but just consuming the data products which were created for them. And of course, it's very important that in the central part of the system, we have on one side interface with the metadata tools. So this is an important component to know how those data which live in our platform, how they are connected to the different business concepts in the organization, which can be done by connecting this to a centralized enterprise data catalog. And on the other side, also the capability to store the data in the storage, because although clearly in the center of our solution there is data virtualization technology, which is kind of the unifying layer for everything, but we do not believe in the narrow vision of data virtualization as being more or less the same as data federation, just live querying of data from different places. What we believe in is the different use cases and also different data sources, different types of data models require different approaches. And sometimes you need to use, or it's best for you to use data virtualization or data federation. Sometimes it's best to replicate the data, historize the data, transform the data in the material way. Sometimes it's important to land the stream somewhere, or sometimes maybe you just need a place to materialize your data product, as Mike said. And all those capabilities are coupled with those central capabilities, with the capability to bring data together as a data execution engine, the kernel of the system, but also with all those services which are needed to address the typical aspects of a data management system, things like centralized permission management, centralized audit logging, and so on. These are things which you would expect from a operating system in enterprise environment, from your Linux or Windows, and this is something which you also can expect from our data operating system. We don't call it data operating system, but again, we like this analogy when we are describing this. Yeah, so I could talk about this for much longer time, but I think it's better to show it once than to talk about for longer. That's why I will just jump into the platform and show you the main elements so you can have a glimpse and like high-level understanding what does it look like. And I will start with the view of a business user, data consumer, somebody who needs data products for their daily work, somebody who just wants to have a place where they can go in and they can explore and discover what data products are prepared for them, and they can consume this in different ways. So here we call it business data shop. And here there is a number of data products which were published for me, and as a business data user, I can consume them in different ways. So I can download this as Excel, and usually the first question some organizations ask, can we disable this button? Yes, we can. The others are happy about having this button still. You can open things directly in Tableau. You can open things directly in Power BI. You can open them in R. You can get a code snippet for your Python machine learning application. You can call it from your web application using API, using HTTP API. You can look at the data lineage. So it's very important to see where the data actually coming from which source system, and from which table there, and from which column. And of course, if this is a citizen data integrator or citizen data engineer, then they are also able to jump into an environment where they can write some SQL and query and crunch their data. If I look from the other side at the system, then I will see that there's a possibility to connect a number of different data warehouses to store the data. I see that there is possibility to connect a large number of different data sources which can be databases, which can be cloud applications, and so on. And for a number of them, sometimes there are tricky configurations which are needed, and this is where our support is just a live chat away to help you connect those things. But of course, not only for connecting data sources, but also in general to help you with the system. Then, as I mentioned, it's important to know the data virtuality is not just about virtualization, but we in fact combine different approaches. We combine things like materialization here, and this is more or less exactly an answer to what Mike mentioned in his presentation. So if our system notices that some data products or some elements of data products are used more often, then we make a recommendation to materialize it in the attached storage, and it's very easy to accept this recommendation, and then the data will be flowing into the storage, and from a virtual product it will become a materials product, so a persistent data product. But of course, it's also possible to create data products as purely material data products by using different replication approaches, which we have in our system. So there is a number of possibilities to model data using plain SQL or using different graphical builders for different types of models. But this is probably too much for today's conversation. There will be links in the chat later. It's actually the SaaS version of this platform is public, so anybody can go and try things out. And there's also some onboarding to show you around. So if you're interested, please feel free to join. Let me maybe use a couple of minutes which I have to jump back from this product view into a use case, so that you can not only see, yeah, okay, that's a technical thing. Obviously, it has different bells and whistles like technical things do, but what is it actually good for? So how, for example, a retail bank could, or how they are using it, and where does it help them? And just for this concrete customer, we actually counted 14 different use cases where they use data virtuality for. And they started just with one use case with financial reporting. So they connected their existing data warehouse to data virtuality, and they were able to remap the data format very quickly into a new reporting standard, which they were able to deliver to the regulator things very quickly, where without data virtuality, they were thinking it's a 6 months project to rebuild their old financial data warehouse. They were also able to use more data, more customer data for better risk management by combining in a live manner, in real-time manner, data from CRM and data warehouse, so that they could actually use more customer data without breaching a GDPR regulation, which does not allow storing too much customer data together. So this was a nice use case. At the same time, with this platform, it's possible not only to have traditional analytical applications, but also real-time analytics. So for example, the sales management team of this bank, they were using data virtuality for real-time tracking of sales of their digital products, of the consumer loans which they are selling. And this is very important for them, because any kind of delay, any kind of hiccup on the market could cause them large losses in very short amount of time. So that's why real time was extremely important for them. At the same time, they were also able to feed this data into their new data science and machine learning department. And this has two ends to it, because on one side, they were optimizing their customer journey through the digital channels together with the marketing and optimizing the customer spend. But also at the same time, they're also doing more advanced calculations about the behavior of their customers, using the data products from our platform. So if you ask me, okay, was it a data mesh, or was it a data fabric, for example? Was it something else? at the end, it was a combination of both, because all of this concept, they both say, okay, we're not a technology, we're not a software, but there should be something, there should be some kind of foundation to enable those organizational or architectural concepts. And for this particular customer, it had elements of data mesh because some of the departments were more autonomous and had more technical capabilities on their side, and they could own their domains more, still running on the same foundation. Other departments relied more on the central technical department to prepare the data products for them. So essentially, like with many things in real life, it was a hybrid concept at the end, but it was important that it worked for each team and each use case in this organization. Yeah, so I am over with my glimpse into the architecture, like the vision, the architecture, the software itself, and some of the use cases. And I'm happy to pass on for the question and answer session.
Okay, thank you, Nick. Thank you very, very much for the presentation and understanding how data virtuality fits into Mike's kind of vision of everything. I've learned quite a lot. Thank you both in regards to that. We did get a couple of questions. One of the questions we had is that will it be possible to have access to the recording and or the slides after the presentation? I'm not going to give that neither to Nick nor to Mike. I'm going to take that one just quick, which is we're going to try and send that to you within the week. So that was a very quick answer, hence I just robbed that question. Then I have a longer question to Mike. So I'm going to try and make sure I get it right. So this is from Robert E. You, Mike, wrote your first white paper on data virtualization usage pattern in 2008. So he's been following you for a long time, I think. And at that time, you described specific use cases such as data warehouse extensions. And today, you discuss DV as a core data architecture capable with the capability of spanning multiple analytical use cases. Do you think that this changes due to more capable DV solutions, broader analytical demands, or some of both?
Okay. Yes. Nice to hear from you, Bob. I think there's definitely several things going on here. I mean, one is absolutely data virtualization has moved on, as I said, to now support multiple data integration techniques, and I think that trend's set to continue. In fact, I would go further. I said ultimately, I think we will see an optimizer go into these kind of platforms to be able to choose the best data integration technique on behalf of the user. But that's still not happened yet. Nevertheless, so I think that extension makes a difference, especially this ability to be able to persist data, also support change data capture. The other thing that's going on, when I first started writing about this and presenting on it, is that that we had these separate analytical data stores. In fact, even the big data scene back in 2008 hadn't even happened. So, but since then we had an explosion of analytical data stores, of which data warehouses were, and accompanying data marts were just one type. And then we kind of moved into, well, if we have all these silos, we need to kind of simplify access. You could put data virtualization over the top of all of those, a kind of sort of logical data warehouse kind of architecture. But I think as we start to see these different kinds of analytical data store coming together, especially with open table formats, and driving integration between streaming and data lakes and lake houses and data warehouse, then you get the ability to potentially support multiple analytical workloads of fewer copies of data. But you still need the ability to quickly build those kinds of systems. So I think data virtualization can be used in two ways. One on the consumer side, where we've always talked about it in the past. We're now talking about it on the production side, and building data products, building virtual data products, building persistent data products. And I think the other thing that's going on is a definite approach to building has changed. Where we would go and build these monolithic data models and build all of the pipelines to produce a data warehouse. We're now moving into the world of component-based development. And that's why data products is taking off, because why do we have to build this monolithic system for a single purpose when we can build these building blocks that can then be assembled quickly for different analytical workloads without necessarily having to copy data? And so I think it's a combination of things that is driving this. It's not just necessarily one thing. I hope that answers your question.
Thank you very much, Mike. I think that was an excellent answer. I've got two questions. I'm going to go with Shailesh as the first one. I'm really sorry if I butchered the name. The question is, this material data products, are you storing data physically in the database? And how can we handle performance? And this question goes to Nick. And Nick, if you can do it in about 2 minutes, then I'm going to try as well to answer Ralph's question. Sorry.
Yeah, that's very easy to answer. So the answer is yes. So if you materialize a data product or a part of data model, then it gets materialized into this analytical storage. This can be something like a Snowflake database, for example, or Azure Synapse database, or there are like 20 other possibilities we have there. And this is at the same time an answer to your second part of the question, how we can handle the performance. So materialization is one of the ways of optimizing performance in here, but we also have other ways. So for example, we have the possibility to do in-memory caching inside of the virtual part of the platform, which is very good for real-time querying. So usually our recommendation is to use more materialization for analytical use cases, for BI use cases, and more caching for real-time use cases. So these are some of the ways to handle performance. So the full answer will probably be too much for 2 minutes.
Thank you. And we'll actually give some contact details afterwards. But before we do that, last question for today, which is from Ralph. And this one goes back to Mike. And how would you rate the maturity of data lakehouse technology as a full alternative to data warehouse technology as of today?
I don't think it's completely on a par at this stage, but I think the big difference now is this emergence of open table formats and, let me say, wide adoption, wide support from data warehouse database vendors. So we're not really looking at this now as just an alternative to a data warehouse, but actually to be integrated with a data warehouse to speed up the ability to get at data in files within data lakes, because the performance of cloud storage, even if you had Parquet columnar files that were compressed, still not very good. But when you look at open table formats, you get hidden data partitioning, you've got metadata that allows you to do data skipping and all of these kind of important parallel query kind of capabilities, which therefore allows you to get far better performance. I think over time we will see over the next couple of years we'll start to see improvements. But I certainly think as more and more databases potentially lean towards open table formats and away from proprietary ones, it does open up the question, does this boil down to, well, is the database just going to be the query engine? And then does that mean therefore that it's a battle of the query engine? And I think that to me is where I think we're headed for in the next couple of years. But right now, I don't think we're fully there yet. But certainly, over the next few years, I think as we see both warehouse vendors and lakehouse vendors kind of moving in similar directions, we're going to start to become more of a par.
Yeah. And I think it's something to be watched. So thank you very much again, Nick and Mike.